Welcome back to another exciting series of videos, and this time around we will learn the concept of system of equations. What is the general purpose of these videos or on this topic is there'll be two broader concepts. Either you'll be given an algebraic expression and you'll be asked to determine the value of a specific variable, or you would be given information from which you have to construct the algebraic expression and then solve the expression to determine the value of a specific variable or multiple variables, right? So once again, welcome back. Let's get started. In the first problem, if you notice, you're given three expressions and you're asked to determine the numerical value of x, right? So let's go ahead and write those expressions first. So 2x plus y minus 3 equals -6. Y plus 2z equals 5, 2x plus 5z equals 19. Let's call these expressions 1, 2, and 3 respectively. If you notice, the first expression contains all three variables, x, y, and z, whereas expressions 2 and 3 are missing at least one variable. For instance, 2 does not contain x, and 3 does not contain y. So your best bet would be to convert 2 and 3 into a certain format and then plug them back into expression 1 for what you're converting it to, and then solve for a variable from which you can extract information about other variables. So here's how you do it. So we know y plus 2z equals 5, right? So you can take y equals 5 minus 2z if you subtract -2z on both sides. So this is the new expression for y. Let's call it 4. Similarly, 2x plus 5z equals 19. We know 2x equals 19 minus 5z. So that will be expression 5. Now, why did I go for 2x is because I can make a direct substitution for 2x here. You could have done it for z. Similarly, in the above expression, you could have done it for z, then you'll have fraction. It just makes things more complicated and you might be spending more time. So try to spend less time, yet achieve the same outcome, right? So let's go ahead and substitute 4 and 5 into expression 1. So in place of 2x, you substitute 19 minus 5z. And in place of 5, you substitute 5 minus 2z. And then you already have -3z. Whole thing equals -6. So the z's add up to what, 10z, and then the numerical values add up to 24. If you add -24 on both sides, then you get -30, so z equals 3. We only need to find x, so we do not even need to worry about expression 4. We could go straight away to expression 5 and substitute for z. So 19 minus 5 times 3, so it'll be what, 4? So 2x equals 4, x equals 2, right? If you even look at the timestamp of this particular problem, you see how fast I did it. Because as I read the problem, I visualized how I want to do it. So that's exactly the habit I want you to get into it. I don't want you to just jump right away and start working out. Just take a couple of seconds to visualize how you're going to solve the problem. In other words, what is your course of action, okay? Especially when you have time constraints, you're under pressure to be right and to secure higher score. So the time definitely plays a part. So as you practice, don't worry about time. But when you take a test or when you try to diagnose yourself, set a standard for yourself. I don't want to do it in a minute. I want to do it in 40 seconds. And then that way you're training yourself to get into the mindset on how I want to visualize the problem and be effective, yet try to solve the problem in a more efficient manner. Okay. So that's why I said, when I created expression 4, I could have gone the other way around by doing 2z equals 5 minus y, but then I'm making unnecessary approximation to get it into fractions, and then I have to take a common factor. It just keeps on looping. Eventually I will get x equals 2, but wouldn't it be easier to take it in terms of variables that I can make an easier substitution? Because y is a univariate, it's easy to substitute. Similarly, I substituted in place of 2x because I can literally substitute one with the other. You want to visualize those sort of things as you do it. The only way you're going to do it is with practice, okay? Let's go to the second problem. This is a rather lengthy problem, and this is the only problem in all of the problems that sort of has this unique complexity to it. So let's go ahead and solve it. The problem states, or at least the problem wants, how many strawberry milkshakes are sold. There's the milkshake stand, and it sells chocolate milkshakes, vanilla, and strawberry, right? The total of these milkshakes add up to 179. Vanilla milkshakes cost $1.30, while chocolate and strawberry milkshakes each cost $1.45. If the total milkshake profits add up to X dollars that's given, and there were 27 more chocolate milkshakes sold than strawberry. Right. The algebraic expression that we write for this problem, as I said, is very unique than pretty much anywhere else in all of the videos, I promise. The rest of the videos, the rest of the problem, the logic may be sort of similar, but this one's different. Only because you know the cost of the vanilla milkshake, but the chocolate and strawberry, it's told it's each cost, right? So we can combine them into a single variable. Similarly, the chocolate and strawberry, they're differing by a certain amount. That is, there's 27 more chocolate milkshakes than strawberry, right? So the strawberry and chocolate are sort of combined into a single umbrella. So if you say A corresponds to, okay, the total of, say, vanilla milkshake, okay, and B corresponds to the total of chocolate and strawberry. This is a total, because we don't want to do it as A plus B plus C. Instead, because those have very similar value of $1.45, we can do it as a combined. So we know total of A plus B equals 179. Another thing I want you to point out, remember, which I will again point out with other problems so that it gets into your mindset, is you add two variables and equate it to a value which doesn't contain any units. Now here it's just a physical count. So you add the count of the shakes and equate it to the total count. In the next case, we know that each vanilla milkshakes cost $1.30. So $1.30 A, which A corresponds to vanilla, and dollar here, we have to equate the dollar to $1. And the cost of the strawberry and chocolate milkshakes combined is $1.45 B, because we said B corresponds to total of chocolate and strawberry, vanilla corresponds to total of vanilla. This is equal to $246.05. If you didn't understand this problem at this point, don't worry about it. Just watch through it. As we go through similar problems, you will understand how I write these expressions, because they all carry very much of a similar note. Okay, let's go ahead and solve for either A or B. We can say A equals 179 minus B, right? So let's go ahead and, for convenience, let's get rid of the dollar symbol. So 179 minus B plus 1.45 B equals 246.05, right? This is part of the calculator section, or you can round off if it is not part of the calculator section, but I know for a fact this was part of the calculator section. So 179.1.3 is 232.7 minus 1.3b plus 1.45b equals 246.05. 1.45 minus 1.3 is 0.15b, okay, equals 246.05 minus 232.7. That's 13.35, right? What is B divided by 0.150? It's 89. So what this $89 is the total cost of chocolate and vanilla milkshake, okay? But what do we know? We know that there were 27 more chocolate milkshakes than strawberries. So let's say C corresponds to chocolate milkshakes. That means there's an S corresponds to strawberry, okay? milkshakes. These two combined add up to a $89 total count, okay? And we know there are 27 more chocolate milkshakes, right? So C equals 27 plus S, right? So that means S plus 27 plus S equals $89. Do you see how we get this expression? Because C plus S equals $89, right? That's the total cost. S can stay as it is, but C is 27 plus S because there's 27 more strawberries. So 2S plus 27 equals 89. So 2S equals 89 minus 27. Sorry if this problem is long, but I don't honestly know if there's an easier way to do this problem. If you can think of even an easier way, please let me know in the comments box below. So that is 62. So S equals 31. So you're asked to tell how many strawberry milkshakes were sold. We know 31 milkshakes that are strawberry are sold. It's a lengthy problem, but here's what I wanted to take away is how to write this algebraic expression. As I said, this problem is very unique as we are combining the chocolate and the strawberry into a B, but all of the remaining problems are not this way. They're much more easier to work with. And here's what I want you to take away even from those problems is how to write the X plus Y algebraic expressions. And as we do more problems, it'll almost become second-handed to you. So please continue watching the videos. And as I do 2 or 3 problems, and if you come across a 4th problem, you're welcome to pause the video, work out the problem, and continue watching. All right, again, consider 3 lines given by the following equation: x plus 2y equals 1, y equals 2x plus 3, 4x minus 3y equals 2. What's the value of the x coordinate that is common to all of the 3 lines, okay? Let's go ahead and when it is a point of intersection, you can take 2 values or actually substitute. Let's say x plus 2y equals 1, right? You have to determine x and y values and substitute in each of the expression and determine if they have same intersection points, okay? This is a very lengthy problem, okay? So if this video is rather long, well, it's gonna be it because this is a long, these are long problems. Y equals 2x plus 3. Go ahead and substitute y in place of y here in this expression. So that means x plus 2 times 2x plus 3 equals 1. So x plus 4x plus 6 equals 1. So 5x equals 1 minus 6 equals negative 5. So x equals negative 1. Okay. If x equals negative 1, okay, then y is what? Y equals 2 times negative 1 plus 3 is negative 2 plus 3 implies y equals 1. So x and y are negative 1 and 1. Okay, let's go ahead and do the same with the other expression. So we'll take say 4x or negative 3y. It doesn't matter which one you want to pick. So 4x minus, let's take 4x minus 3y equals 2, right? So let's take negative 3y equals 2 minus 4x, right? So y equals 2 minus 4x over 3, right? So let's go ahead and substitute that in the expression for x plus 2y equals 1. So x plus 2 times 2 minus 4x over 3, right, equals 1. So that is x plus 4 minus 8x over 3 equals 1. So if you take 3 as a common factor, it'll be 3x plus 4 minus 8x equals 3. So that'll be what? Negative 5x equals 3 minus 4 is negative 1. So x equals 1 over 5, right? Did I do my math right? It's correct. So now let's substitute this x equals 1 over 5 into any of the y expression that you want. So we know y equals 2 minus 4 times 1 over 5 over 3, right? So that's 2 minus 4 over 5 over 3. So that will be 10 minus 4 over 5 over 3 over 1, right? So that is 6 over 5. I'm going to finish the calculation here. 6 over 5 over 3 over 1, right? Right? Did I do my maths right? Okay. So that means 6 over 5 times 1 over 3, that's 2 over 5. So when x equals 1 over 5, y equals 2 over 5. These two xy values don't match, right? The intersection point for these two is -1 and 1, and the intersection for these two is 1/2 and 2/2. These two values are not same, so that means x does not have, there is no point of intersection. These lines, or other words, these lines do not intersect. Because these values don't match, these values are not the same. If two lines intersect, then they have a common point of intersection. Because these two xy value pairs are different, that means these lines do not intersect. I apologize if these two problems are long, but I can't think of any other way to solve these problems. Even if this were the exact same question on a SAT exam, this is probably the only way you can go ahead and solve this problem to figure out an answer for this problem, okay? All right, each sheep has 4 legs and each chicken has 2 legs. If a farm boy counts heads and 50 heads on 140 feet, how many sheep are there? Let's take our common knowledge, okay? Humans have 2 legs, right? And sheep has 4 legs, right? Or say, in this case, sheep has 4 legs and chicken has 2 legs, right? So the legs is part of the feet number, right? Whether it's chicken or sheep, it has only a single head, right? In other words, if we call, okay, head as, okay, head of a sheep as X, and head of, okay, or of you know, or in other words, sheep as X, or and a chicken as Y. Doesn't matter at this point, okay? What is critical is, don't confuse the head and the feet, because one thing is common, other thing is different, which is head is common for both animals, right? And feet amount of legs is different. So we can say that the literal count X plus Y is 50, right? Because X head plus Y head equals 50 head, right? I just didn't write the head because of, for mathematical reason. Similarly, the legs is part of the feet, right? So we have 4X. That's why I said you have to keep it the same. Whether it's head or legs, let's add legs as well. What is critical is the sheep and the chicken are the variables, okay? These are components of the animal, but the animal themselves are the variable, right? So we have associated sheep with X, chicken with Y. So 4X plus 2 is Y equals 140. Because the 4 and 2 are components of the animal, which is the legs. Similarly, 1 and 1 here corresponds to the head, but the variable themselves are the animals, okay? So now we have it in a form where X plus Y equals 50, 4X plus 2Y equals 140, okay? That means you can either multiply by 4 here, that will give you 4X plus 4Y equals 200. Why did I do that? Because I want to get rid of one of the variable and get the answer in other variable. Easiest would be if I multiply by 4, then I can cancel out. If I subtract, then I can cancel out the X term, which leaves me with 2Y equals 60. So Y equals 30. We know Y is chicken, right? But we want to know how many sheep are there. If X plus Y equals 50, if there are 30 chickens, and X corresponds to sheep, how many sheep are there? It's 50 minus 30, equals 20 sheep. Okay, it may be a little bit complicated for some of you. Some of you probably understood by now and said, I got it. But some of you may still be having trouble with the algebraic expression. You would always have two different components, either dollars or in this case heads. And then you will have some other variable which may be same as feet. So you always have two different things, okay? The count, a physical count is equal to physical count. So when you add two variables that are counts, that is X amount of heads, Y amount of heads, that's equal to heads. Similarly, 4 legs means the X corresponds to the sheep, so the 4 goes with the X. Y corresponds to chicken, so the legs of 2 goes with the chicken, okay? Don't mix them. Because it's X and Y, because I can, no matter how I'll get X and Y, no. If you had put 2X plus 4Y, you wouldn't get the same answer, okay? You will not get the same answer, okay? Because above you've said X is sheep and Y is chicken. So you have to add whatever coefficient with the appropriate variable before you can complete the algebraic expression and proceed to solve it, okay? If 8X minus 9 is 10 less than 5, what is the value of 4X? Okay, 8X minus 9, okay, is equal to 10 less than 5, right? 10 is less than 5. That means it's not 10 minus 5, it's 5 minus 10, right? 8X minus 9 is 10 less than 5, right? Unless you write this expression correctly, you won't be able to solve this problem. Maybe if this was, again, this was a multiple choice, maybe using a choice, you might be able to come up with some shortcut. But again, if you don't know what the basic is, then again, you will struggle. So it says it's 10 less than 5. So 10 is less than 5. So that means 8X minus 9 equals negative 5. 8X equals negative 5 plus 9. That would be 4, right? Right? So X would be 4 over 8 equals half, right? Isn't that right? Okay. So what is 4X? That'll be 4 times half will be 2. Once you get the expression, again, you see, when you get the expression here in the above part, we could solve. Again, if you write the expression, then we could solve. That's the whole point of the system of equation is you'll be given a set of conditions from which you have to derive an expression with which you'll be able to solve. I think I made that clear when we first started. This sort of problem is quite common on a GRE exam and some ACT, although I've not seen this type of comparison problem on a SAT test so far. I saw this and so I thought, okay, let me use it. So again, you know 4X minus 5Y equals 12. 6Y minus 3X equals minus 6. So here you have quantity A and quantity B. Quantity A is X plus Y, quantity B is 6. Okay, so how can we get X plus Y? We have to either get X and Y and add them together, or if you can somehow get the expression in terms of X plus Y, that'll work as well. So if you notice here, the equation is flipped. So 4X minus 5 equals 12, write them in the correct order because you may get carried away and solve written as it is. I just flipped it so that it looks aligned. So if you just add these two expressions, then you get X plus Y equals 6. So we know X plus Y equals 6. So quantity A is 6. A equals B, right? 6 equals 6. So the two quantities are equal. Okay. In this case, because it was a simple addition and I was able to get X plus Y, which then equated to 6, in some cases, you may be able to, you should be able to convert Y into X, make a substitution, and from which you will be able to get X and then solve it back into the expression to get Y and then add X plus Y. That's one way of doing it. But then because there are so many difficult problems, they would have to give you some easy ones to compensate for time, which is why this problem happened to be the way it is. Okay, if X plus 12 equals 28, what's the value of 3X plus 2 times minus X plus 10? It's a very, very simple problem. All you have to do is solve for x. So if x plus 12 equals 28, then x equals 28 minus 12, which is 16, right? So let's go ahead and solve for the numerical value of this expression here. So it's 3 times 16 plus 2 times negative 16 plus 10. So this is 16 minus 16 times 3 is 48 plus 2, okay, times negative 16 plus 10 is negative 6. So 48 plus 2 is 50 times negative 6 is negative 300. I don't see how this is a difficult problem, but you need to know how to do these problems as well. Now, this problem that's below the soccer player problem was written, if you can actually visualize it. So what I keep saying when you do the system of equation problem, or for that matter, any problem on an exam, is as you read the question, try to visualize what is the course of action, what it is that is given, and how you can manipulate what is given to make sense of what is being asked, okay? So here, a soccer ball is kicked at 8 meters per second. A player runs to receive it as soon as the ball is kicked at a speed of 4 meters per second. If the receiving player starts at 12 meters ahead of the ball, how far does he travel before he gets the ball, right? So here's how it works. So, okay, the player is actually starting 12, if this is where the soccer ball is kicked from, okay, this is the start. He's got a head start of 12 meters per ball, okay? The ball is kicked at a speed of 8 meters per second, okay? So eventually the ball would land somewhere here, okay? So he is starting from here, okay? This is where he is starting. He's got a head start of 12 meters from where the ball is starting. This is where the player is. Okay, he is going at a speed of 4 meters per second. Means if this is where they catch up, okay, they're asking how far would he have traveled from the start had he started from here. But you only have to figure out this portion here. Then you can add it to the 12 to figure out how far he would have traveled from the start, okay? Okay, so what's the best way to do it is, we know speed equals distance over time, right? So we know that these two speeds have to be equal, or two distance have to be equal, or two times have to be equal, because eventually the player and the ball has to catch up. So two things have to be equal. That's the common aspect here. So in one case, say, let's look at from the player's perspective. We know the speed of the player and the distance he has taken. So we can figure out the time, right? If time's equal, which means whenever time's equal, that's when the player and the ball will catch up. So from a player perspective, we know its speed is 4 meters per second, which is equal to distance is 12 meters over time. Okay, so time is 12 over 4, which is 3 seconds, right? So for a player, we know it would take 3 seconds to go from here to wherever the ball would land. Okay, so let's look at for the ball. For the ball, what do we know? We only know the speed and we know the time now, so we can calculate the distance, right? So for the ball, we know the speed is 8 meters per second. We don't know the distance, we do know the time. So 8 times 3 is 24 meters. So the ball would have traveled a total distance of 24 meters, right? The player already had a 12 meters. So here's what it looks like ultimately. You have the ball has traveled 24 meters, okay? The player had a head start of 12 meters, and then you're asking how far he has to travel from this place where he's starting. He had to travel 12 more meters. Please don't think he has to travel 24 meters. The ball is traveling 24 meters. He was already at 12 meters. He only has to catch up the ball, which means after the 8 meter per second kickoff, the ball has traveled a total duration of 3 seconds and 24 meters. To get to 24 meters, He has 12 meters, which means he has to run 12 more meters to catch the ball here. So the answer is 12 meters, not 24 meters. You see, this is literally how I had visualized the problem after I read it. Of course, I didn't think it this fast, like I explained it to you, because I've already worked the problem. It has taken me less time. But when I first looked at it, this is the way I thought. Okay, the player is starting here. This is exactly the figure I drew. As you see, as I began to construct the problem, I started adding values and variables into it and then figured out what it is that I want. But this is literally how I imagined, even though it's soccer, I imagined it in terms of NFL. And that's the game I watched quite a bit, and that's what I've come to used to. So they both have balls, so it didn't matter. So I envisioned NFL, that's why I kind of drew the projectile motion. I think even soccer has projectile motion, but I just related myself to the game and then drew the picture, and from which then I worked my way up using the knowledge of physics and then my own common sense, and then I worked out the problem. I got the right answer, which is 12 meters. Okay, this is the last problem in this video. Again, this is one of those XY problems. This is from here, it's much easier. A farmer sells only apples and oranges at his stand. Apples are about $half each, and oranges are 65 cents each. If he makes $33.45 in a day after selling 55 total pieces of fruit, how many of each fruit he did sell? So let's say X corresponds to apples, because this is the variable, not the amount. Again, how much he sell or what's the price is not the variable. The variable itself is apples and oranges. So Y corresponds to oranges. So we have two quantities here. One is the total pieces, which is physical count, and then the other is the price. So X plus Y, total number of apples plus total number of oranges equals 55. Okay, we said X corresponds to apples. So our cost of apple is 55. So the 0.55 goes with the X. Similarly, 0.65 goes with Y. That's equal to 33.45. I'm not including the dollar sign for convenience. So now we can substitute either X or Y for X or Y in any one of the expressions, however you want to do it. Let's say Y equals 55 minus X. So I substitute, let's call this expression 3 into expression 2. So that means 0.55X plus 0.65 times 55 minus X equals 33.45. I believe this problem was part of the use of calculators. So all you have to do is 0.65 times 55 is 35.75 minus 0.65X equals 33.45. And this is 0.55X. So that means 0.65 minus 0.55 is negative 0.1X equals 33.45 minus 35.75. So 35.75 minus 33.45 is 2.3. Okay, this is negative as well. So X equals divided by 0.1. Okay, so that is 23. We said X is apples. So how many of each fruit did he sell? Well, you're asked to determine quantity of both X and Y here. So that might be the only difference you will see throughout this. How do you write the algebraic expression will remain the same. How is the outcome processed will be different. So we know 23 apples are sold. Okay, so we know X plus Y, the physical count is 55. If he had sold 23 apples and Y is oranges, he would have sold, what is it, 55 minus 23 would be 32 oranges. Now this question could literally appear as just amount of apples he sold, or how many oranges did he sold, or how many of each of he has sold, and that's the option whoever wrote the question took. So that's how you do this problem. The takeaway is how you write the algebraic expression. I'm sure as we finish this 5-part or 6-part series videos, you would be very comfortable writing algebraic expression, I guarantee you. Some of you may get it first time, some of you may get it only on the 5th video, but I promise by the time we finish the 5-part series or 6-part series, you would be very, very comfortable with the idea of system of equation. You can always expect this sort of problem on a typical SAT exam. So thank you for watching. Please consider subscribing to my channel and share the videos with your friends who are also equally interested in learning mathematical problems for the SAT exam or ACT exam. So stay tuned for the remaining videos on this topic. I'll see you soon.